Right now, we are going to present an online address by Dr. Raiiv Singh. Dr. Raiiv Singh is the Vice President of CMP Slurries Entegris, and he had been in academia for the last 30 years, professor at the University of Florida. But more interestingly, he is one of our alumnus. He had done his Bachelor of Engineering from Jadavpur University in the 1981-1985, this particular time frame. So it is over to Dr. Raiiv Singh. We would try to touch base with him. There he is. And can we please let him know in chat that he is online, and he can start.
Can everybody hear me?
Please send him a chat saying we can hear him.
Good afternoon. I'm Raiiv. I would like to present a short talk on my last 30 years of work in US, but also would like to thank the speakers, the audience, as well as the organizers for listening to my talk and inviting me to make a presentation. I have had, since graduating from JU in 1985, I have got my PhD in material science, and then I was a professor at the University of Florida for 30 years, 1990 to 2020. And in the meantime, not only I was involved with a lot of research and development, but also commercialization of my patents. And that would be more of a discussion after this. So let me share some slides. If I can get that. Yeah, so there it is. So what I'm going to talk to you today is some of the applications of nanoparticles, which are used in the semiconductor industry. And I would basically talk more in the terms of especially applications coming electric vehicles. See if I can move my slides here. It's just okay. There it is. So the outline of my talk will be introducing two companies which I have founded about 20 years back while I was a professor at the University of Florida. And these two companies, one was in biotechnology, nanotherapeutics, and other was in semiconductor processing, SynMat. And both these companies were sold in the last 2 years, 3 years, with over $400 million in sales exit. These companies employ about 400 people and have over $1 billion local economic impact. So what I wanted to emphasize is R&D, along with innovation and commercialization of this, leads to strong and very prosperous economic development. And that's what I would like to emphasize. Innovation is very, very critical as we go forward. I'll give you a little bit more examples on what science we have been working on, especially with super hard materials, which are used in electric vehicles, and also example of sapphire, which is used in consumer electronics. Finally, I wanted to also mention is R&D as well as commercialization is not that easy. a lot of startups fail. Almost 95% of the startups will fail. And so one has to really be quite careful as well as persevering to have the right ways to be successful. So the first company which I established in 1998 was in sustained release of insulin, and then it morphed into vaccine manufacturing, which is basically helping the manufacturing of mRNA vaccines currently, which is a very big deal, as you know, with the COVID. It employs about 350 people and has major economic impact in the town, which in Florida. The second company which I established was Sinmat, which is basically develops a polishing technology for new types of electronics. And the new type of electronics is like silicon carbide instead of silicon, which is used in electric vehicles like a Tesla car, where you can increase the battery mileage by 10% or 50 kilometers just by having more efficient electronics, and also the charging time to less than 20 minutes by having higher voltage electronics, power electronics in the vehicle. And that's really helping to foster this whole EV revolution because it's making the battery much more efficient. The other materials I'm involved with is sapphire. Some of these you're quite familiar, are used on all different smartphones, and coming up with different types of methods how to make them better from engineering viewpoint. So this company is basically, the area is called chemical mechanical polishing, is about 10%, 15% of the semiconductor industry, which is a $500 billion industry. So about a $45 million, $30 to $40 billion type of processes being used in the semiconductor industry. And this company, Sinmat, was acquired by Entegris for $75 million plus. So very, very successful outcomes. And the key for all these has been innovation, where a lot of patents get developed, and then the challenge from patents is to commercialize. And as you can see, even if we established the company long back, it takes 10 to 15 years to commercialize these and then being able to make a successful sale. So it's hard work, a lot of change challenges in between, but one has to have certain things in place which will help us move to the next level. So coming back to the silicon carbide process, as you know, high charge. So if you want to run the motor in a EV, the DC battery power has to be converted into high volt AC, and this is done by solid state types of electronics. And silicon carbide is a new material which is being used for decreasing the battery charging time for Tesla, as well as increasing the battery mileage. In fact, if you look at a car which is going 400 miles, just the semiconductor part of it helps to increase the mileage by 40 miles, which is a massive increase if you were using only silicon electronics compared to the silicon carbide electronics. So wanted to mention what is chemical mechanical polishing. It's basically something which you're quite fit polishing of materials, except that it has a mixture of chemical and abrasive particles. And by controlling the chemistries as well as the abrasives, you can polish it faster and without defects. In semiconductors, there cannot be any defects. So if you use a very hard abrasive, it can cause scratches. That's not useful. So one has to come up with better processes to polish these materials. And we have been using special chemistry synergies and I will talk a little bit more about that. So if you look at materials which are being used in the emerging semiconductors, as you know, diamond is one of the hardest materials. It's uh, uh, also very chemically inert. So same thing about silicon carbide, which is maybe the third or fourth hardest material. Sapphire, which is alumina, is also super hard material. So the challenge is when you try to do a CMP process, you also have to have chemical action, and these being inert materials do not give you chemical action. So being able to innovate and come up with new types of ways to be able to do that is very, very important. And that's what we were able to do and make it a commercial success. So the two technologies we have been working on is one, you take a particle, typically 100 nanometer size, being able to create some sort of surface activated states so that you can react with the inert material and polish it faster. So that's how we are polishing silicon carbide. In terms of some other materials, we take small pieces of diamond, which is typically in the 100 nanometer or less, and attach it to a larger particle. And by doing that, we can polish things much, much faster. So simple things, but innovation takes time, and being able to demonstrate that has helped us come up with new methods and also beat the competition. So just to show you an example of silicon carbide, the surface, which you can polish very fast, but also the surface is so smooth that you can see the atoms on the surface itself on a atomic microscope. So you can polish it without any damage, and that's what you need by being able to come up with these processes for the semiconductor industry. Same thing with gallium nitride. This is a material which is used in all LEDs currently, and also for new types of power electronics. And both these materials, we have come up with technologies which has helped us to move to the next plane. So just as an example, US is the leading silicon carbide electronics semiconductor companies, have the leading semiconductor companies in the world. We have about maybe currently 80%, 90% of the world market. And for one of the manufacturers, we developed this process. The process time decreased from 50, 60 hours for this process to 1 hour. And you can imagine how much cost savings comes in and increase in throughput of this material. And that has made us the biggest supplier of this type of slurries, we call them, to the whole industry. Just as a side note, as you know, diamond is one of the hardest materials known to man. And by applying and the only way people think of polishing diamond is using diamond, because you need to have a harder material, similar hardness material to polish. But we are, by using this chemistry plus very soft talc-like abrasives, can polish diamond very, very well. So this is example of a diamond film made in the lab, and by this rubbing with these special chemicals and abrasives, you can make it atomically smooth on the surface, and that has major ramifications currently. In fact, there's a very big industry of artificial diamonds used for jewelry coming up in the market, but also for electronics. We are pioneering that area, because now you can make large area diamond substrates which are very, very smooth for electronic applications. Similarly, another material which you're very familiar with, you use it on a daily basis, smart watches, smartphones. Some of these surfaces are made of glass, but some of these surfaces also made of sapphire. And what we've been able to do is use this approach, the new approach, by which we can create very smooth surfaces of, of sapphire by using this nanodiamond CMP process. And you can make this happen much, much faster and much quicker, decreasing the cost of this product. So this is example to show you the removal rates or the polishing rates increase by a factor of 50 compared to the standard processes people were using, and the surface finish is also amazing. So both these things have helped to make this one of the very unique products which we have in the market. And one example of that has been that we've been working with a very large, one of the largest US-based company, and we have been able to change their process from several days to several hours, a factor of 40x improvement in the time taken by being able to come up with these new technologies. So that's has propelled, these technologies have propelled us as a world leader in emerging semiconductor applications, and that's why we've been able to sell the company at a very high level, and also being able to now further continue R&D in that direction. So basically what I wanted to, this is my last slide, wanted to mention that we have had two very successful nanoparticle startups, greater than $400 million in value exit, 400 plus employees creation, $1 billion impact. And this is not the only impact my research has done. I have graduated a lot of students, maybe over 50 students, PhD students, published several papers, 500 papers. But for me, having this achievement has been more because I can see very tangible benefits to the society, as well as helping to improve not only towards climate change, but also creating so many jobs in the local market. So that has been very, very, very highly satisfying. And the keys, what I've realized for success is basically it's always people. If you have the right people who are having strong skills, but also able to persevere, a good team who are all aligned, that really helps for success. As you know, that it takes maybe 10 or 15 years, and the pathways are not straight, they're up and down. So it's very important to make sure that the team is very, very important. It looks like a very successful approach for me, but there have been several times where the technology has not worked, things have not really done well, and there have been a lot of failures in between. So one of the key things we have been able to do, which has helped us success, was to develop a flexible platform technology, which means that you can pivot very easily and quickly, given the personnel to be able to try new things. And that is what has helped us to move forward. The R&D itself has a lot of risks. Most of the timelines get pushed out, takes much longer than anticipated. It's very, very challenging, especially if you have no money. So a well-funded business plan and rapid innovation, which is given by a platform technology, is very, very useful. And we have, this is something which you have to be aware of. There are always shifting market dynamics, commoditization, and new competition coming up. And what we have been able to do is look at innovation. Basically, innovation is key. Having the infrastructure for innovation helps you to come up with new products. Some of these products we have were so out of normal evolution that we were able to capture the market even you are a small company. And so that has been very, very useful. Scalability in manufacturing is a big challenge. And here also you can decide what you want to do, what things you really want to really focus on. We focused on slurries, which was more scalable. We could have focused on making the substrate, would have been more challenging. So choosing the right business model was very, very important. So with that, what I would like to say is this, I've been really blessed with a lot of success, not only as a professor, as a innovator, but also being able to be very successful as an entrepreneur, able to start from scratch and develop uh, technologies and products which have been very useful for a lot of different applications. And it's been my team and a lot of passion, along with a lot of innovation, which has been keys to our success. I would like to conclude, and I would like to answer any questions you may have. Thank you.
Thank you so much. That was Dr. Raiiv Singh joining us from the US.